This is the study guide for Unit 4A. Number 1, determine the following if the following are functions or not a function. When you're looking at graphs, what you need to perform is called a vertical line test. So if you take the vertical line and move it from left to right, and it's not going to let me move it from left to right, you can see that this particular graph, it only touches at one time at any place, so therefore this one would be a function. This one would not be a function because it fails several times along the way. It's touching up there as well as down on that one. Now we'll go to this one, and it is good. It only touches one time. And then let's take it and try this one out. All right. So looking at these, what you encounter is this, that this one is a function. This one is not a function. This one is a function. And this last one is a function. All right. Now let's look at number 2. Determine what type of function each graph represents, linear or nonlinear. Well, if we're looking at this one, you can tell that this is a line, and it's not a vertical line, so therefore, it could be a function. So this one is linear, and then this one, you can tell that it passes the vertical line test as you move it from left to right, but it's not a straight line, so therefore this is nonlinear. All right. Number 3, determine which type of function each equation represents, linear or nonlinear. We have 4y to the first power equals negative 2x to the first power plus 6x to the first power minus 8. Note that all my variables are raised to the first power. So this would be a linear function. All right, y equals 2 raised to the x. Well, y is being raised to a first power, but this x is now up in the exponent. So it is a non-linear function. Y equals 4x minus 2. You're going to see that y is raised to the power of 1 here, and x is raised to a power of 1. So therefore, that, by criteria, is a linear function. And then y equals x cubed minus 1. Y is raised to the first power. X is raised to the third. So therefore, we know that this one is non-linear. All right. What is the difference between the following tables? Well, first off, let's look at slope. Change in x. So that's 1 and 1. Let's look over here. And then we have, that's 3, and then that's 6. Well, if we're looking at slope, for this one, change in y over change in x, that's 3 over 1 and 6 over 1. You can see that they will not simplify down to be just 3. So we have 3 and 6. So that particular one, well, the x's don't repeat. So therefore, this one would be a non-linear function. All right, now let's take a look at this one. Look at our change in x, and every one of them is changed by 1. Look at our y's, our change in y's. That's going down by -2. We can tell that our change in x's is 1, and our change in y's is -2. So we've got slope as -2/1, which is just -2. Erase that. Kind of crazy there. All right. All right. Now, so we've calculated the slopes on these. So it says table 1 is not a function. Well, none of the x's repeat, so therefore a is out of the question. Table 1 represents a linear function. Well, we said table 1 was a nonlinear. Table 1 represents a nonlinear function. Okay, I agree. And table 2 is not a function. Well, table 2 is a linear function. So get my cursor back here. There we go. There. So we know that's a linear function. So C's out. D, table 1's a nonlinear and table 2 represents a linear. So D is the answer. 5. Which of the following diagrams represents a function, and how do you know? Well, in a mapping, which A and B are, you're looking at x values and you're looking at y values. And in a mapping, the x values are only going to show up one time, no matter if it's a function or not. So what we need to pay close attention to is how many lines are coming out of each x value. There's one line coming out of this one. There's one line coming out of this. There's 2 lines coming out of this 9. And then 1 line coming out of 15. So this is not a function because of the 2 lines coming out of 9. Now let's look at B. You got 1 line coming out of 3, 1 line coming out of 10, 1 line coming out of 11, and 1 line coming out of 13. So that is a function. 6. Determine if the following tables are functions or not a function. If they're a function, are they linear or nonlinear? Well, first off, this one, that's a function. This one is not a function. Okay, it's not. So we're going through on the first swipe and we're going to say, hey, which ones are functional, which ones are not. Because 1 has 3 as an output and 1 also has 5, so therefore it's not a function. 0, 1, and 4, now the x's repeat, so that's a function. 4, 7, and 10, those are functions. Now let's go back and figure out. All of these are changing by 1. Now that's 6, and then that is 18. Well, that change, because that's 6/1 and 18/1, and you can't reduce those because your denominator is 1. That just means you're 6 and 18. That's not a, that's a non-linear function. All right, let's look here. 0 to 1 is 1, 1 to 4 is 3, so that's your change in x. Change in y. 5 to 9 is 4. And then 9 to -27. Well, that would be -38. Okay, -38. So we have 4/1 and -38/3. This doesn't simplify down to 4 over 1. So that is a non-linear function. All right, let's look at the last one. 4 to 7 is 3. 7 to 10 is 3. That's your change in x. Here's your change in y. 2, 5, and 15. That is 3. And then that is 10. So we have 3 over 3 and then 10 over 3. Well, that simplifies to 1, but 10 over 3 won't simplify to 1. So this one is a non-linear function. Okay? Which of these functions has a greater rate of change? Well, greater rate of change is nothing more than slope. And we know that 2, the slope for this one is 2. Let's find out what the slope is for the table. That is change of 1 apiece, and then, of course, negative 6 to negative 3 is 3. You're going up the number line, and negative 3 to 0 is 3. So you have 3 over 1. Which has a greater rate of change? Is it 2 or 3? Well, 3, which means the table has a greater rate of change. Now, which set of ordered pairs represent a function? Well, if I'm looking at ordered pairs to see if there's a function or not, then I'm looking to see if x repeats with a different y value. So this x, 1, 2, 2. 2 repeats here and there. Now it's got a 3 and a 4. So this one is not a function. Okay. 0, 5, and 5. Well, 5 is with 1 here, and 5 is with 4 there. So that's not a function. 0, 2, and 3. Okay. None of the x's repeated. So that would be my one function. Let's see if there's another one. 0, 5, and 0. Now 0 here has 5, and 0 here has 4. So that is not a function. Okay. 9. Which of the following tables represent linear relationships? There may be more than one. Well, let's look at them. We got to turn around and find change in x and then change in y. This is 1, 1, 1, and 1. Now, the really good thing about when you're changing x is 1. If you have anything that is different over here in your y and you're changing y, then you can automatically say it's a non-linear relationship. Okay, so 5 to 10 would be a 5. 10 to 12 is a 2. And then 12 to 16 is 4. And 16 to 20 is 4. Well, all of these are over 1, which means they're all whole numbers. Okay, 5, 2, 4, 4. Well, that's not linear. It's a non-linear. Okay, so table 1 is a non-linear function. Now, let's look at this one. Looks or appears that all of our change in x's are going to be 1s. So we got 10, 10, 10, and 10. Because all my x's are changing 1 and all of my y's are 10s, then the slope on this is 10. So table 2 is a linear relationship. Now, let's look at table 3. Again, all of my x's are going up by 1. Okay, change in x. Let's look at change in y. That's negative 2, negative 2, negative 2, negative 2. All of these are the same, and they're all over 1, which means that my slope is -2/1, which is -2. So table 3 is linear, or it has a linear relationship. Now, which of the following, or which of the functions below, has a greater rate of change, slope, when compared to the table? Well, first off, let's go do the table. So those are all 1. And these are -5. So this is -5/1, which equals -5. Now, the slope for this one is -2. The slope for this one is -6. Okay. The slope for this one is -7, and the slope for this one is -5. Now, we're saying which of the functions below has a greater rate of change when compared to the table? Well, when you're comparing slopes, you've got -5, -2, -6, -7, -5. You look at it without the sign. So you take away any negative slopes and kind of look at it in terms of an absolute value. So when we're looking at this, we're only looking at just 5, 2, 6, 7, and 5. So which of the functions below has a greater rate of change when compared to the table? Well, that would be B and C. 6 and 7 are a greater rate of change than 5. And I know they're negative, but when you compare slopes, you do not take the signs into account. Now, which function has a greater rate of change? Let's go ahead and get our tables done. So we should see that this is 3/1, which is 3. Now, I'm going to do this. If you can see this, this is 1, and that is 1, 2. So that is change in y over change in x. That is 2/1, which is 2. So which one has the greatest rate of change? Well, my table. You could pull these 2 points off, and you would have 0, 3, and then you would have 1, 5. And you could perform the same thing. Okay, you can do this, and you'd still get 1, and that'd be 2, and that'd be still 2/1. So there's multiple ways to get slope on that. Which triangle with hypotenuse AB is similar to the triangle with hypotenuse BC? Do AB and BC have the same slope? Explain the reasoning. Well, let's see. 1, 2, 1, 2, 3. Now let's change colors. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, so let's look at the purple. The purple's over here. So we're going to look at change in y over change in x, which is 2/3. And then we'll check and compare the red, which would be and that's 4/6. Now we should see that 4/6 simplifies down to 2/3. So therefore, these slopes are the same. Okay, so the slope of AB is 3/2. No, we said 2/3. So what they've done is they made a mistake, and so if you grab this one, you put your x on top and your y on the bottom. The slope of AB is 13 and BC is 52. No. The slope of AB is 2/3 and the slope of BC is 4/6. The slopes are the same because the scale factor of the similar triangles is 2. Well, we'll come back and look at that. So that one looks pretty promising. 2/3 and 4/6, the slopes are not the same. Well, yes, they are. If you reduce them, they are the same. So I want you to kind of look at this. Says the slopes are the same for C, but because the scale factor of the similar triangles is 2. You remember dilations? So if this changes and y is 2 and this is 4, so how did I get from 2 to 4? I multiplied it by 2. And this run, this x, changing x, is 3. How do I get it to be 6? I multiply it by 2. So it does have a scale factor of 2. So the correct answer is C. Now, 14, 15, 16, 17, 18, 19. Let's take a look at those. All right, what is x when y is 0? So we're going to look right here. Y is 0, x is what? 8. Now, let's go through and see if we have any more that are y or zeros. No. Okay. Y is blank when x is 7. Well, let's go find x is 7 up here. I've got it right here, and then do I have anywhere else? No. So what is the y value when x is 7? That would be 2. X is blank when y is 5. So let's look on the y's for 5. And there's only one 5, and its x value is -2. Y is blank when x is -2. So let's look on the x's till we get -2. There you go. That's the only one there. So its y value is 5. The x-intercept. Well, when you have the x-intercept, y equals, guess what? 0. So let's find 0 for y. Looking down, there it is. So what is the x-intercept? 8. The y-intercept is when x is equal to 0. So let's look on the x. Let's go to 0. There it is. Do I have any more? Nope, right there. So the y-intercept is -2. Now, find the x and y intercepts of the following equation. Well, if we're going to do that, we should set y equal to 0 for the x-intercept and x equal to 0 for the y-intercept. Okay? In doing so, I have 3x plus 4 times 0 equals 24. Okay? So what I'm left with is this. 3x equals 24 divided by 3. So x equals 8. That's the x-intercept. Okay. Now let's look at this one. Let's go to green. X is 0 on the y-intercept. So 3 times 0 plus 4y equals 24. So 4y equals 24. Divide by 4. So the y-intercept equals 6. All right. Last problem. Complete the table for the following equation. So this is 7 times -3 minus 3. So that's -21 minus 3 is -24. 7 times 0 minus 3. Well, that's just -3. 7 times 3 minus 3. 7 times 3 is 21. Minus 3 is 18. 7 times 6 minus 3. 7 times 6 is 42. Minus 3 is 39. And then 7 times -1. Oh, that's a -1 there. Let me fix that. All right, 7 times -1 minus 3. So that's -7 minus 3 is -10. Okay, so what we've done is we plugged in every one of these x values in for x, evaluated it, that's the process, and got an output of y. This concludes the study guide for Unit 4A.